All right, so in this lesson, we are going to be reviewing how to simplify radicals and also teaching you what fractional exponents mean in terms of roots. So on your notes, I kind of just go over the basics of simplifying a root. For example, let's say you had the square root of 18, but this was not given to you as a square root of 18 if you were dealing with triangles for the last couple assignments. It was written as a number on the outside and a number in the inside of the root. So if you do this on a calculator, the square root of 18, I'll just go ahead and do this with you. The square root of 18 is going to, let's say it's going to be 4.24 approximately. And then if you do the 3 times the square root of 2, you're going to get approximately 4.24 and change. These two are the exact same answers. The reason why is because this is a simplified version of the other one. So I'm going to be reviewing how to break down these specific roots. You should have talked about this last year in IM1, but if you didn't, that's fine, or if you don't remember, or if your teacher didn't do it, that's fine. I'm going to go over this really quickly. I'm going to use this example to, let's just use square root of 18. And we're going to break this down into two numbers, into a factor tree. So there's a couple different ways you can do it. So I'm going to do square root of 18 two different ways. We have to break it down into two more square roots that will multiply together to get 18. So what two numbers multiply together to get 18? Well, there's a couple set. Let's start off with 9 times 2. Okay, these are just little arrows just breaking this down. Another set of numbers you could use is square root of 6 times the square root of 3. It doesn't matter how you do it because you're going to get the exact same answer no matter what you do. Now look, the way that I do it is I say break it down into a factor tree, but I don't write in the notes. I don't write this next step. I say I want you guys to start on the left-hand side with each number and try to pull out a square root. So look, the square root of 9, you can actually pull out a square root, which is a whole number of 3. And after you're done with this, cross it off, and then you'll work your way up to the right. What else do you have? You have the square root of 2. If you can't pull out a square root or you cannot break it down anymore, then you're going to circle it. And the very last step I say on your notes is you multiply everything together. 3 times the square root of 2 is 3 square root 2. See, that's the exact same answer. It's the square root of 18, what we just did. Now, let's say we do square root of 6 times square root of 3. I'm going to continue breaking down this square root because I can factor square root of 6 even more. I can say square root of 6 is the same thing as saying square root of 3 times the square root of 2. So I haven't changed the value at all. Now, continue doing what I just did. Can you break down square root of 3 anymore? No, the answer is no. Once you can't break it down anymore, you're going to circle it. And then you're going to continue over to the right. Can you break down the square root of 2? No. Now, you still have this square root of 3. Can you break down this square root of 3? No. Okay, so now you have everything circled. My answer has to equal 3 root 2. This isn't going to equal 3 root 2 because look, if I multiply the square root of 3 times the square root of 2 times the square root of 3, I'm going to be back at square root of 18. But let's look at this. Whenever you have two roots that are the same, because technically we're doing this, we're doing square root of 3 times the square root of 2 times the square root of 3. And with multiplication, it doesn't matter the way in the order that you do it. So look, Let's say I multiply square root of 3 times the square root of 3. That's going to give me the square root of 9 times the square root of 2. The square root of 9, you can actually pull out a whole number, which is the square root of 3 and then the square root of 2. 3 times root 2 is equal to 3 root 2. Now, if I went kind of fast for you, think about it like this. Whenever you have two roots that are exactly the same, the shortcut is they cancel out and you're left with the number inside of it. Square root of 3 times square root of 3 just cancels out to be 3. With this square root 2 circled, there's nothing else you can do with these two, which become this. I just broke this down a little further conceptually, showing you how you get this. What you should always try and do is try and use two numbers when you're breaking down a factor tree so that those two numbers, one of those will pull you out a perfect square root. Let's start off with square root of 200. I'm going to do this a couple different ways. And you're going to see it's easier to try to pull out a perfect square root. Square root of 200 can be simplified to the square root of 100 times the square root of 2. All right, that's good. Square root of 100 is the same thing as, well, square root of 100 is 10. So I can't cross that out because I don't have to deal with that anymore. 10 is a whole number. Once you get a whole number, you just circle it. Square root of 2, there's nothing else you can do. So square root of 100 or square root of 200 on your calculator is the same thing as saying 10 times the square root of 2. If you don't believe me, go ahead and do that on your calculator. This is the same answer as this. Okay. Now I'm going to do a couple. Let's say you do square root of 100 times square root of 2. Let's say you did this. Let's say you did square root of 10 times the square root of 20. Or let's say you did square root of 50 times the square root of 4. It doesn't matter how you do it, but you're going to see doing it with numbers that don't pull out nice, perfect square roots right off the bat is a lot more work, but it's still going to get you the same answer as 10 root 2. All right, let's look. I can break down square root of 10 to give me square root of 2 times the square root of 5. This doesn't have a perfect square root, but there's nothing else I can do. Square root of 5 does not have a perfect square root, but there's nothing else I can do. All right. Now, square root of 20. Let's break down square root of 20 times this. It's the square root of 4 times the square root of 5. I think that'd be the easiest too. Or square root of 10 times square root of 2. Doesn't matter. All right. Square root of 4. Continue breaking down this side. I'm done with this. Once you break it down, you have more steps. Square root of 4 actually has a perfect square root, which is a number 2. And the square root of 5, I can't simplify that anymore. So look, this is my whole number. So I have 2 times, look, remember what I told you a second ago? The square root of 5 times the square root of 5 is just 5. Because square root of 5 times the square root of 5 is the square root of 25. And the square root of 25 is 5. So the shortcut, whenever you have two numbers that are the same, you're just left with the number inside. Okay, lastly, the square root of 2. 5 times 2 is 10 with the root 2. See how if you use smaller numbers, you're going to get the same answer. It's just a lot more steps. Well, let's try this one now. Let's try square root of 50. You're going to see square root of 50 is still going to give me this answer. It's just going to be more steps. If you don't try to use the biggest square roots you can pull out right off the bat, it's just a lot more steps, but it's going to give you the same answer. Okay, square root of 50 is going to be square root of 25, let's say, times the square root of 2. Square root of 25 is 5 as a whole number. Square root of 2, there's nothing else I can do. Now I come back over to the square root of 4, because 50 times 4 is 200. Square root of 4 is a whole number of 2. You just multiply, after you've crossed off everything, you multiply everything you circled. 5 times 2 times root 2. 5 times 2 is 10 with the root 2. It doesn't matter what numbers you use. All right, I want you guys to try square root of 32. Try to pull out a perfect square root. Pause the video and see if you can do it. Okay, I'm going to do this 2 different ways because I know both ways. Some of you guys probably tried to do it. Probably some of you guys did this. This would be the easiest way. Square root of 16 times the square root of 2. Square root of 16 is 4 with this root 2. So your answer is 4 root 2. That's your answer. Some of you guys might have done this. Square root of 8 times the square root of 4, which is fine. It's just a little more work. Let's break this down. Square root of 8, I can break it down to the square root of 4 times the square root of 2. Okay, continue breaking down this left side. Square root of 4 is actually 2. That is the square root of 4 is 2. This, there's nothing else I can do. Come back over to what you haven't touched yet. What is the square root of 4 over here? It is 2. Now you're going to multiply everything. 2 times square root 2 times this 2. 2 times 2 is 4 with that root 2. Okay, the very last one, 105. Let's see if we can break it down. 105. Square root of 105. Well, I can pull out, go square root of 5 times the square root of 21. Square root of 5, I can't break that down any further. Square root of 21, I can break down into square root of 7 times the square root of 3. Square root of 7, I can't do anything with. Square root of 3, I can't do anything with. Notice you could not pull a simplified, you cannot pull a whole number from here, here, or here. So whenever you can't pull out a whole number to get a perfect root, you're left with the original equation. So the square root of 105 simplified is the square root of 105. Okay, next one. This is a little more in depth. This is a new concept. Roots are fractional exponents. Do you know why conceptually the square root of 16 is equal to 4? Well, it's equal to technically it's equal to plus or minus 4, but let's not get it that far down the line. Let's just say the square root of 16, one of the answers is 4. The reason why is because, look, whenever you have the squared root, the reason why it's called a squared root is because there's a little invisible 2 in front of that root, always. And then there's also, watch, 16 to the first power is actually still 16. These two numbers are very important when it comes to fractional exponents. If this was, let's say, the cube root of 8. This is asking, what number multiplied by itself 3 times gives me 8? The answer is 2, because 2 times 2 times 2 is 8. The answer is 2. The reason why this answer is 4 is, what number multiplied by itself 2 times, meaning the number multiplied by itself again, gives me 16. 4 times 4 is 16. 2 times 2 times 2 is 8. This is called the cube root. This is called the squared root. The reason why these little numbers are important is because you are going to be asked this now. You're going to be asked, for example, what is 27 to the 1/3 power? You can do this in your head. You just might not know that you can do it in your head. If you were to do this on your calculator, do this on your phone right now, on your calculator. Do this. 27, you probably have to do this. 27, and press the arrow button, press the parenthesis 1 divided by 3, close the parenthesis and press equals. It's going to spit you out 3. 27 to the 1/3 power is 3. Now let me explain this to you conceptually. Do you see on your notes, I say this numerator is always your exponent. Your denominator is always your root. Think of it like this. This 1 drops down because there's going to be a root here. This 1 drops down and it shoves this denominator, boop, outside of the root. It shoves this outside of the root. This is the number inside the root. This 1 drops down and it becomes your exponent. And it shoves the 3 outside of the root, or whatever is your denominator outside. So here's your question now. Instead of 27 to the 1/3, break it down into a root. What is the cube root of 27? And then, once you know that answer, you're going to raise that answer to the first power. What number multiplied by itself 3 times gives me 27? The answer is 3. 3 times 3 times 3 is equal to 27. That's why the cube root of 27 is 3. And then you're going to raise it to this exponent. 3 to the first is equal to 3. So this is what you do. You are going to do this. What is the cube root of 27? 3. And then raise that number to this exponent. 1. 3 to the first is 3. Why do I raise it to my first? It's because that's the original question. The cube root of 27 and then raise to this number. Hopefully that made sense. Let's try another question. You're going to have questions where it's going to ask you, what is 64 to the 2/3 power? You can actually do this in your head. But before you do anything, always change it into the root. Always change it into the root. This 2 drops down. This 2 drops down, becomes the exponent, and it shoves this 3 outside of the root. And then the way you solve it is this. Cover up the exponent. What is the cube root of 64? Meaning, what number multiplied by itself 3 times gives me 64? The numbers are going to be really small. The answer is going to be really small. So, look, 2, is it 2? Is 2 times 2 times 2, if I multiply it 3 times, that equals 8. It doesn't equal 64. 3, let's try 3. 3 times 3 times 3 is equal to 27. 4 is 4 to the 3rd, 64. 4 times 4 is 16. 16 times 4 is 64. So look, the cube root of 64 is 4, but then you square it, which is equal to 16. So if you were to plug 64 to the 2/3 in your calculator, you would get an answer of 16. Okay, let's see if you can do the second to last one. 25 to the 5/2 power. Let's see if you can do that. 25 to the 5/2 power. Pause the video and see if you can do it. You can do it in your head. You should be able to look at this and go square root of 25 and then to the 5th power, which is equal to 32. That's your answer. How? Well, look, this 5 drops down. It becomes the exponent. That's why I say in your notes this is the exponent. And when it drops, it does this. Boop! It shoves the 2 outside of the root. And then the way you do it is this. What is the squared root of 25? What number multiplied by itself twice gives me 25? The answer is 5. Oh, actually, sorry, it's not 32. It's much larger than 32. It's 5 to the 5th power. And 5 to the 5th power, 5 to the 5th power is equal to 3125. So if you were to do this on your calculator, 5 and then raised to the 5/2 power or raised to the 2.5 power, you're going to get 3125. And this is the reason why. Okay, ladies and gentlemen, the very last question. Let's see if you can do this without a calculator. 32 raised to the 4/5 power. Pause the video and see if you can do this. Okay, if you paused it, you should have done this. 32 to the 4/5 power is the same thing as the 5th root of 32, whatever that answer is, to the 4th power. Because this 4 drops down, and when it drops down, it shoves the denominator, boop, outside the root. So here's your first question. What's the 5th root of 32? What number multiplied by itself 5 times equals 32? The answer is going to be 2. The 5th root of 32 is 2 because, look, 2 times 2 times 2 times 2 times 2 is equal to 32. And a lot of people ask, how do we know this? How do we know what numbers they are? It's always going to be probably in between 1 through 6. The way IM2 is, you're never going to have any answers that's going to be some huge number to figure out the root. It's always going to be a number between 1 through 6. Okay, so 2 to the 5th is 32. So the 5th root of 32 is 2. Is that your answer? No, because remember, this is your exponent. So 2 to the 4th is equal to 16. This is your answer. If you were to plug 32 to the 4/5 in your calculator, you would get an answer of 16.